Hello, Algebra 1. I'm Mrs. Leong, and I'm going to go over lesson 2.6 about ratios and proportions. All right, so starting with some vocab, a ratio is a comparison of two numbers by division. So a ratio of x to y can be expressed in three different ways. You can literally just have x to y. You can have x colon y, or most commonly we see is x over y. All right, and that's just comparing two numbers with division. All right, now a proportion is an equation that states that two ratios are equal. So for example, I have a ratio of A over B being equal to C over D. So this whole thing is considered one proportion. All right, now B and C, specifically in this proportion, those are called the means. Whereas A and D, these are called the extremes of that proportion. All right, and now why that's important is because there is the means extremes property of proportion, which states that in a proportion, the product, all right, the product, when you multiply the extremes, it's equal to the product of the means. All right, so what that means is when you have a proportion like this, when you do the product of the mean or the extremes, it'll be equal to the product of the means. So A times D is equal to B times C. All right, and that's what the means extreme property tells us. Okay, so let's go ahead and use some of that in some examples. So if you look on page 115, number 12, all right, it says 4/3 and 6 over 8. All right, so we want to determine if 4/3 and 6 over 8, are those considered equal? Okay, so well, let's use the means extreme property. If they were equal, hypothetically, if these were equal, the extremes, 4 times 8, would be equal to 6 times 3. In this case, that is not true. This is 32, this is 18, so that means these are actually not equal ratios. So I'm going to say no. And it does say justify your answer, so I'm going to say by the means extremes property. All right. And that would be my answer for number 1. Okay, let's try it again with number 14. This one, it's 39.68 over 60.14, and we want to see if that's equal to 6.4 over 9.7. All right, so let me go ahead and use that means extremes, and I'm going to multiply 39.68 times 9.7. All right, let me use a calculator for that one. And I get 384.508. And if I do the extremes, so 6.4 times 60.14, I get 384.896. So we're close, but not quite. Oops, sorry. I think I made a mistake. Sorry. When I typed in my numbers, I typed that in wrong. So sorry. When I did 39.68 times 9.7, it actually was 384.896. So actually those are equal. So yes, those are equal. And again, by the means extremes property. All right, and even though you are doing it on calculator, please show the work. That helps with the justification of your yes or your no's, okay? All right, let's go on to example 3. So on page 115 still, and we are now on number 24. All right, this time we are asked to solve each proportion, meaning we need to find the value of a variable. All right, so for number 24, this is 2.4 over 3.6, and we want to see if that's equal to k over 1.8. All right, so again, using my means extremes property, I'm going to go ahead, I'm going to multiply the extremes, so I get 3.6 times k is equal to 2.4 times 1.8. So I'm going to do that on my calculator. And I get 4.32. Continue to solve. I'm going to divide by 3.6. And I get 1.2. All right. So that's how you solve a proportion. Okay, number 28. Very similar. This time we have 7 over x plus 9 is equal to 21 over 36. Okay, actually something I noticed first is that 21 over 36, I can reduce that. You don't have to, but I think it would actually make life a little bit easier to have smaller numbers. So I'll divide top and bottom by 3. So I get 7 over 12. And again, you can do the means extremes. We can do 7 times x plus 9 is equal to 7 times 12. Just make sure you put parentheses around that entire x plus 9. All right, so that whole thing is being multiplied. And that way you remember to distribute. And then go and subtract the 63. And we get x is equal to 3. All right. And that is how you solve when your variable is in a proportion. Okay, let's go to this next part right here. Now, this time we're talking about some rates. All right, so some like real world type problems here. Now, a rate that tells how many of one item is being compared to another item is called a unit rate. All right, so for example, if you guys like go to the grocery store, you're gonna see like, oh, the meat is, $2.80 per pound. All right, something like that, or price per gallon. All right, if you're going to the gas station. All right, so that is called the unit rate. All right, now a rate is called a scale, and it's used to make a scale model. If something's too large or too small to be convenient at an actual size. So like, maps do this. It tells you like, okay, an inch is like this many miles, things like that. All right, so those are scales and scale models. All right, so let's go ahead and practice using some of that. So page 115 still, number 30, says the Be Clean car wash washed 128 cars in 3 hours. At this rate, how many cars can we wash in 8 hours? All right, so we can set up a proportion here, comparing cars washed to hours. So we know that 128 cars were washed in 3 hours, and we want to know how many cars can be washed in 8 hours. All right, so that is our proportion. Okay, so let's go ahead and do our means extremes. We're gonna basically cross multiply is what it's called. All right, so that's our means extreme cross multiply. 3x is equal to 128 times 8, which is 1,024, I believe. Let me double check that. My calculator, I did that too fast. Oh, nope, all right, that is right. Okay, and then divide both sides by 3. All right, and that gets me 341.3 repeating, all right, and 1/3. All right, so about how many cars can they wash? I can leave it at that many cars, but I think it just kind of makes more sense to leave it as a whole number. So I'm going to say about 341 cars in 8 hours. Since I guess the the guy in the 1/3 is just still working on that car, we won't count that as a finished car. Okay, nice. Number 6, we have an artist use interlocking building blocks, I'm assuming Legos, to build a scale model of Kennedy Space Center in Florida. In the model, 1 inch is 1.67 feet of an actual space shuttle, and the model is 110.3 inches tall. How tall is the actual space shuttle? Round to the nearest 10th. All right, so let's set this up. So we know that 1 inch is equal to 1.67 feet, and the model is 110.3 inches tall, and we want to figure out how many feet is the actual space shuttle. Okay, so notice inches matches with inches, feet matches with feet. All right, so it's important to get the order of those proportions correct. All right, so if we cross multiply here, I get, I'll do this one first since this one has my variable x. So I'll have x is equal to 110.3 times 1.67, which I will do on my calculator to get 184.201. It says round to the nearest 10th, so I'm going to do 184.2, and this is now in feet. All right, and that is it for lesson 2.6. Good job.